Hello viewers, welcome once again. I am Teacher Jeff and it's mathematics. The topic is trigonometry 3, part 2. So I had already covered the first part, which was about the relation sine squared theta plus cos squared theta equals to 1 and the application. So if you go back to the previous part, you can find everything we explained and how you're supposed to use this in relation to expressions as far as trigonometry is concerned. So right now, we want to focus more on trigonometric equations. And for the equations, we'll have to revisit something that you did in Form 3 because it might be needed in the questions that we'll have to work out later on. So, and by this I mean, if you remember trigonometry 2 in Form 3, they taught you something to do with a unit circle. So, I'm not going to explain the unit circle in details, but just talk about the things that are required in the unit circle, then how we are supposed to use it in this topic here. So now, unit circle was a circle. Now, if you say unit circle, simply means a circle which is 1 unit. So we assume it's drawn on a Cartesian plane, where this is the y-axis and this is the x-axis. If this is the origin, divides this circle into 4 parts. So about the unit circle, there are 4 major things that you're supposed to know. The first one being, once you divide it this way, you divide the circle into 4 parts, referred to as quadrants. You're supposed to know the names of the quadrants. Starting from this here, this is referred to as the first quadrant. This is second quadrant. This here is third quadrant. And this here is fourth quadrant. So the names of the quadrants. Quadrants are named anti-clockwise, starting from here. First, second, third, and fourth. Like I said, I'm just reviewing, but if you maybe forgot about this information, listen carefully because anything I explain is what we'll use to solve the equations that we'll do later on. So now, the second thing you're supposed to know is, of course, this is a point. The angles start from this line here, 0. So total angles back to this point are supposed to add up to 360. Angles at a point add up to 360. Because of that, at least you're supposed to know the angles that are required in each of these quadrants. In the first quadrant, which is this, the angles to find here will be between 0 to 90. Because there is 0 up to this point, you can see it's a right angle. So any angle that is acute, any angle between 0 to 90 degrees is normally found in the first quadrant. Then there is the second quadrant. Second quadrant is this here. The angles here, you can see this is like 180. So if we have 90 already, so the angles in this quadrant should be between 90 up to 180 degrees. Then in the third quadrant, this quadrant here, next after 180 should be 180 up to 270 degrees. Then in the fourth quadrant, the angles in the fourth quadrant will be between 270 degrees up to 360. That's the second thing that you're supposed to know about angles, the place where you find angles. So that if someone says, where do you find angle 230 degrees? Looking at that, you should know, of course, it's supposed to be in the third quadrant. If we talk about 290 degrees, you should know that it's in the fourth quadrant. If I say 110 degrees, it is in the second quadrant, and any acute angle that's between 0 to 90 degrees should be in the first quadrant. Okay, the next thing, these are 2 things I've explained. First, the names of the quadrants and where you find them. Next, I've explained about angles found in each of these quadrants. So the next thing, which is kind of very special, is there is relationship between angles, 4 angles, and those angles found in these different quadrants. So we'll call an angle in the first quadrant as theta. And in this case, we want to refer to theta as any angle which is acute, or any angle between 0 to 90 degrees. So with theta theta relates to some other 3 angles in these other quadrants. And the angles, as you were told in Form 3, I said I'm just reviewing, so you should know the information. Theta relates to an angle in the second quadrant, which is the same as 180 minus theta. I'll write them first, then maybe use an example to show what I mean by that. Then in the third quadrant, it will relate to the angle 180 plus theta. And in the fourth quadrant, 360 minus theta, where theta in any of the case is the angle here. So, for example, if you're told, give other 3 angles that relate to 30 degrees. So it means 30 is in the first quadrant. The angles we are talking about should be in the second, third, and the fourth. So the first angle, or in the second quadrant, it should be, you will say 180 minus the theta dimension, which is 30 degrees. So it's 180 minus 30 degrees, which is the same as 150 degrees. In the third quadrant, it should be 180 plus theta, where theta was the acute angle, which was 30 degrees. So it's 180 plus 30 degrees, which is equivalent to 210 degrees. The next one, in the fourth quadrant, relating to theta, which was 30, should be 360 minus theta, which is 30. So it's 360 minus 30 degrees, which is 330 degrees. So anytime you have an angle, say in the first quadrant, you use it to relate to other 3 angles in the other quadrants by following what I've just explained here. Relationship between those angles is given by that. In the third quadrant, you'll say 180 plus theta, and so on. Okay, so this, like I've said, take it serious, because when we start the explanations, even though I won't wrap this unit circle, it will still remain there. I'll always refer to it. I've talked about relationship between these angles and said how important it is. So it's theta, 180 minus theta, 180 plus theta, 360 minus theta. Okay, next. Next is the fourth thing that you're supposed to know, another special one, is in these different quadrants, that's for angles between 0 to 360 degrees. There is the trigonometric ratios, which are sine, cos, and tangent. You know them. So for those trigonometric ratios, when you find the value of a ratio, angle of a ratio, you're supposed to get an answer, which may be in a decimal form, 0 point. That's for sine and cos. But if it's tan, it can be any value out there. So the answer that you get after you say, for example, sine 60, that answer that you get, it can either be positive or negative. It will have a positive sign on it or a negative sign on it. Using, for example, let me use an example in the first quadrant. If I said sine 30 degrees, or cos 30 degrees, or tan 30 degrees, I expect the answer on the calculator to always show positive values, because any of those values in the first quadrant should give you positive answers. So the signs that will have those values that you get will always be positive. So now, this means that in the first quadrant, when you look for the values of the sine, cosine, and tangent ratios, the answers of all of them will be positive. So we say that all the 3 are positive. In the second quadrant, that's any angle between 90 degrees up to 180 degrees. Now in this case, it's slightly different. And you can try it, because I'm assuming as a math student, you have a calculator somewhere, you can check these things as I explained. So if you try any angle, let's pick an angle like maybe 120 degrees. For 120 degrees, if you check sine 120 degrees, the answer will be positive some numbers. If you check cos 120 degrees, the value should be negative 0 point some numbers. If you check tan 120 degrees, 120 because it's in the second quadrant, the answer should be negative something, that value there. So just checking this on calculator gives you this value. So it means that in the second quadrant, two are negative, will always give you negative values, but one will give you positive. The one that gives you a positive answer in the second quadrant is a sine. So in the second quadrant, we are only considering those values which are positive. So in the second quadrant, only sine is positive. In the third quadrant is actually here. Any angle between 90 degrees, 180 degrees up to 270 degrees is said to be in the third quadrant. So for the third quadrant, which values will be positive, which values will be negative? Any angle in the third quadrant, say 200 degrees. If you said sine 200 degrees, the answer you get here should be negative. If you said cos 200 degrees, the answer you should get should be negative. If you say tan 200 degrees, the answer you get should be positive. Then conclusion in this is, in the third quadrant, only positive will have a ratio, or only tan will have a ratio that is positive. But for sine and cos, the ratio should be negative. So in the third quadrant, only tan is positive. Then in the fourth quadrant, an angle like 300 degrees, which is found in the fourth quadrant, 300 degrees. So for 300 degrees, the ratio should be, if it was sine 300 degrees, I expect the answer to be negative. If it's cos 300 degrees, I expect the answer on the calculator to be positive. And if it was tan 300 degrees, I expect the answer to be negative. So the conclusion is, in the fourth quadrant, only cosine will have a positive ratio. The other two will be negative. So fourth quadrant, cos will be positive. So now, those are the three major things you're supposed to understand or know about the unit circle. And I've said that, know about the quadrants, know where the angles, certain angles are supposed to be found, know the relationship between angles in all these different quadrants. Then lastly, know the signs of different ratios in different quadrants. So in the first quadrant, they're all positive. In the second quadrant, only sine is positive. In the third quadrant, only tan. And in the fourth, cos. So that said, next is, we now want to try, use this in application as I promised, as far as the questions of trigonometry are concerned. So this is what they'll ask you. They'll ask you a question like, starting from very simple questions. A question like, given that cos theta equals to 0.5, and the value of theta lies between 0 to 360, find the possible values of theta. Okay, a simple question, it's not that hard. But what you should know is, when you talk about cos being 0.5, before I even go deep into the question, just from what I've explained, you notice that between 0 to 360, cos is positive in two places. So from this, I expect the value of theta to have two answers from any of those four quadrants. So the process of doing this starts with, first of all, you get what you call the working angle. And the working angle is given by, on your calculator, you'll say, you'll find the inverse of 0.5. So you say shift, then cos 0.5. That should give you an answer which is 60 degrees. So once you get the 60 degrees, next is, come to this ratio here, check the sign just before the number. Is it positive or negative? In this case, it is positive. Then ask yourself, where is cos positive? According to this unit circle here, cosine is positive in the first quadrant and in the fourth quadrant, because in the first quadrant, all the three ratios were positive. In the fourth quadrant, only cos was positive. So it's in this and this quadrants there. So because of that, you will say, then the value of theta should be, in the first quadrant, like I've said, the answer should be acute. So it will be the same as this working angle here, which is the same as 60 degrees. But the next answer, which should come from the fourth quadrant, is given by, remember the relationship between angles in different quadrants. And in the fourth quadrant, it was 360 minus theta. So you'll have to say 360 minus theta, which is the working angle, 60 degrees. So 360 minus 60 degrees gives you 300 degrees. So this is how you work out this question. And by the way, today we're only focusing on this basic range, which is 0 to 360. Maybe next lesson I will use some different range because it's not all the time that questions asked will be, the domain should be between 0 to 360. It might be some different values. So any questions I'm doing today is just between 0 to 360 first. And unfortunately, I wrote this as theta x. It's supposed to be theta because the value we're talking about is theta in this case. So I just changed. It's theta we are looking for. So if you look at this, the answers are that clear. They're from the first and the fourth quadrant, and all the two angles are between 0 to 360. So that is it. The second example, that's the first example. Second example, given that sine theta equals to negative 0.5. Let me still use the 0.5. Negative 0.5. Find the value of theta, given that theta lies between 0 to 360. Same process. But anytime I explain a question, of course you expect that there is some change. So the change in this part is there is a negative involved. So in this case, when I'm doing the question, I'll get what I call the working angle. And working angle is given by shift sine. Forget about this sign here, just the number. Shift sine 0.5. So shift sine 0.5 without the negative gives you 30 degrees. That's the working angle, which happens to be in the first quadrant. Then now, once you get this value here, the next step is go for the exact values, and which would be found at where now you come consider this sign now. You ask yourself, where is sine negative? Sine is negative according to this unit circle here. Sine is negative where there is no A and S. It means in the third and in the fourth quadrant. Because in the first and second quadrant, as you can see, means sine was positive. So sine is negative in this third and the fourth quadrants, which means the correct values of theta should come from those two quadrants, which is third and fourth. But remember the relationship between angles in these quadrants. Our working angle, which is acute, theta is 30 degrees. Same in the third quadrant is given by 180 plus theta, which is 180 plus 30. 180 plus 30 should be 210 degrees. Then in the fourth quadrant, it would be 360 minus theta, and our theta in that case was 30 degrees. So it should be 360 minus 30, which is the same as 330 degrees. The third example, and as usual, anytime I'm explaining anything to do with this, there should be some difference. So you watch for the difference as I keep giving the examples. The third example is 2 sine squared theta equals to 0.5. So in this question, clearly there is a coefficient of sine. There is also sine squared, things that I didn't explain. So there are two things that I'll explain in the same question. So first, any question, if you come across any question where there is a coefficient of the ratios, the first thing that you should do is you have to get rid of the coefficient by dividing on both sides by the coefficient. So this should be divide by 2, which would give you sine squared theta equals to 0.25. Next step, the squared. So you have to get rid of the square sign. To do this, on both sides of the equation, you find the square root of on both sides. So which would be square root of sine squared? square root of 0.5. Square root of sine squared theta is sine theta equals to 0.5 square root is the same as 0.5, but square root of any number is always plus or minus. Okay, once you get to this now, it's close to the normal questions we're doing. The only difference will be, in this case, there is plus or minus, which should be explained. So next, get the working angle. How do you get the working angle? Same process. You say the shift log 0.5. So if you want to get the angle, you say shift log 0.5. Shift log 0.5 should give you a 30 degrees. And this is the acute working angle I'm talking about. So next should be, after I get this value, I come to these signs here. There are two signs. There is a plus and minus. Then ask yourself, where is sign either positive or negative? And actually, in any of these four quadrants, sign can be positive or it can be negative in any of them. So it means if there is plus or minus, consider angles in all the four quadrants. So for this question, it should be theta equals to, in the first quadrant, it will be this working angle, which is 30 degrees. In the second quadrant, it will be 180 minus 30 degrees, which is 150 degrees. In the third quadrant, it should be 180 plus 30 degrees, which is 210 degrees. Then in the fourth quadrant, it will be 360 minus 30 degrees, which is 330 degrees. So in this question, unlike the other questions, we have four answers. In the other examples that I used, there are only a maximum of two angles. That's the value of theta between the range of 0 to 360. But if there is plus or minus, expect that. Next example, example D. Three sine theta, 3 sine theta equals to 5 cos theta. 3 sine theta equals to 5 cos theta. Now, like I already said, anytime I give any example, there should be something special in it that you have to listen to well. Now, in the previous chapter, before I do this question, I explained the relationship between sine, cos, and tan. And I said that sine theta over cos theta equals to tan theta, provided the values of theta in all the three cases is the same value. So if it's so, then it means this is how you relate the three. If you want more on this, you can review the previous chapter that we did last time, then you can understand that better. So for this question, if you know that, then it means you can use the concept to work out this. So looking at this question, I can see there's theta, theta, but there's sine and cos. And anytime there's an equation, then there's only sine and cos with the same value theta. Then think about sine theta over cos theta equals to tan theta. So what you do is connect like terms in this case. I can see sine theta. On this side, I divide by cos theta, divide by cos theta. And on this side, I divide by 3 by 3. In so doing, I have sine theta over. So when you divide this number on the other side, it would be cos theta. Then equals to, there was a 5. This goes the other side and becomes 3. That's the first part. Then now next is sine theta over cos theta. According to what I've just explained, or the other rule is, this statement here is the same as tan theta, which is equals to 5 over 3. Now look at the question. Just like the other previous questions, this should be solved. Next is get the working angle. And the working angle is, in this case, it's 59.04. So once you get the working angle, and how do you get the working angle? Obviously, you said shift tan 5 over 3 should give you this value. Once you get this value, check the sign. In this case, the sign is positive. Ask yourself, where is a tan positive in the 4 quadrants? Tan is positive in the first quadrant and in the third quadrant. So the answers I'm supposed to get for values of theta between the range 0 to 360 should be in the first quadrant and in the third quadrant. So for the first quadrant, it will be this acute value, which is 59.04 degrees. Then in the third quadrant, it's 180 plus 59.04 degrees, which should be 239.04 degrees. Now, next is, and by the way, all the questions I've explained, even for someone who is in Form 3, should be able to relate and do this. It's part of questions you can expect because it might have been explained in Trigonometry 2 once you talked about the unit circle. So, but now, for someone in Form 4, there is a slight difference between the questions I've just done and now what I want to explain. And you find that for the questions mostly asked in exams, they're based on what I'll now explain. Okay, a slight change. Starting from the simplest values again. If I had a statement given that cos 2 theta equals to 0.5, given that cos 2 theta equals to 0.5, let me make it negative. And that theta lies between 0 to 360s. Find the possible values of theta. So listen, first in this question, unlike the others, theta has a coefficient which is 2. So instead of saying theta, now we have 2 theta. Another thing I want you to notice is theta lies between 0 to 360. But what do we have here? 2 theta. So notice that there is a difference between theta and 2 theta. So if theta lies between 0 to 360, this is how I'll start to approach the question. I'll say if theta is this, how about 2 theta? Then 2 theta should lie between 0 to 360. No, not 360, it's you multiply this by 2 to get 0. You multiply this by 2 to get what? 720 degrees. So that's where it begins. So we have 2 theta 0 to 3, 720, but theta is between 0 to 360. The original question was find the value of theta, not 2 theta. But to get theta, you have to work out values of 2 theta first. Once you get them, then you use them to get the value of theta. So this is the process. First, get the working angle. Just like in the first case, you'll say shift cos without this sign 0.5. So shift cos 0.5 gives you 60 degrees. Once you get this 60 degrees, now you go back to this negative sign here. Then ask yourself, where is the cos negative? Cos is negative in the second and in the third quadrant because, as you can see, it's clearly positive in these 2 quadrants. So now, where is cos positive? Negative, it's negative in the second and in the third. So I'm supposed to get the answers in those 2 quadrants, but the values I get refer to 2 theta. 2 theta and not theta. So I'll say 2 theta equals to, in the second quadrant, it will be 180 minus the working angle, which is 60. That should be 120 degrees. In the third quadrant, it will be 180 plus theta degrees, which is, plus theta, which in this case will be 180 plus 60 degrees. And 180 plus 60 degrees should be 240 degrees. Now look at this. According to this statement, 2 theta should be between 0 to 720. What I have here is just values 120 and 240. So it means maybe there's some other values that I should add, provided I don't get any value which is more than 720. So looking at this unit circle, 360 is like the first revolution. Then if I go the next revolution, gives me 720. So now, these answers I got are between 0 to 360. I want to get some other angles which are 361 to 720. How do you do that? It means the next revolution, the quadrants will still remain the same. This means you're starting again. So in short, this is what you normally do. On any of these values that you got, in the first case, simply add 360 on each of them. So you say 360 plus 120. 360 plus 120 is what? 360 plus 120 is 480. Then again, 360 plus 240. 360 plus 240 equals to 600. That way. So now, 600, 720. If I decided that I want to add 360 on these previous pairs, I'll get an answer which is more than 720. So you just make sure that you get angles that will give you values less than 720 degrees. So from this, I had 120, 240 as my first pair. Then on each of these pairs, I added 360. On this value 360, I got this. On this value, I added 360, got this. So once I get these angles, the angles represent 2 theta. And 2 theta is okay because it was supposed to be between 0 to 720 degrees. Now, to get the value of theta, it's simply these values of theta, divide each value by 2. So which would be 120 divided by 2. The answer is 60 degrees. 240 divided by 2, 120 degrees. 480 divided by 2, 240 degrees. 600 divided by 2, 300 degrees. And indeed, once you get these answers, you will realize that the values of theta that you got are actually between 0 to 360, just like the question asked. Another example, just in case you didn't really get that clearly. It's almost the same, but there may be a slight change. So sine into brackets 2 theta plus 10 equals to 0.48. So my question is, given that theta lies between 0 to 360 degrees, find the value of theta in this equation here. That's if this equation is supposed to be true. So just like I explained, same process. And first of all, okay, this is theta, but this is 2 theta. So for 2 theta, the values of 2 theta, which I'll start calculations with, should lie between 0 to 720, each number multiplied by 2. Okay, this is 2 theta. So the process will be the same. First, get the working angle, which is a shift sine 0.48. Shift sine 0.48 should be 28.7 degrees. The next step is check the sign here. The sign is positive. Sign is positive in the first quadrant and in the second quadrant. So the answers I'm getting represent 2 theta plus 10, everything in the bracket, which is equals to, since I said they should be from the first quadrant and second quadrant, in the first quadrant it will be 28.7 degrees. Then in the second quadrant, you will say 180 minus 28.7 degrees. 180 minus 27.8 degrees should be 151.3 degrees. Now, I got the answers from the first and second quadrant of the angles between 0 to 360. But this is 2 theta. 2 theta should be up to 720. And that's why I said that on each of these values, add 360. Provided whichever answers you get should not exceed 720. So then, in the first case, I'll say 360 plus 28.7. 360 plus 28.7 is 388.7 degrees. Then the next one, 360 plus 151.3. 360 plus 151.3 is 511.3 degrees. So this is what it means. It means if I want to add some more values on the last pair that you had, add 360. But obviously, if you say 360 plus this, you'll have an answer which is more than 720. So it means this is the maximum point you can get to. Then now, the values, this represent 2 theta plus 10. So to get the value of theta, on each of these values, subtract 10, you'll say 28 minus 10. This is just a normal algebra, a question like 2 theta plus 10 equals to 28.7. So when you're working out this, this is 2 theta equals to 28.7 minus 10. 2 theta equals to 18.7. Then you get the value of theta by dividing this value everywhere by 2 on both sides. So it should be something 9.35. So I will do that to all these values. So on every value, I'll say 28.7 minus 10, whichever answer I get, divided by 2, should be 9.35. The next one, it should be 151.3 minus 10 divided by 2. The answer should be 70.65. Next one will be 388.7 minus 10, whichever answer I'll get, divided by 2, and the answer should be 189.35. And the last one will be 511.3 minus 10, then divided by 2. The answer is 250.65 degrees. So look, if you look at this, you notice that the value of theta is just what was asked. They said theta should be between 0 to 360. And my values of theta after the calculation are actually between 0 up to 360. None of the values is less than 0 or more than 360. And by that, you can know whether you're correct or wrong. How you can prove it, if you took any of these values, let's say like 9.35, then replace it with theta, say 2 times this value plus 10, you should get this answer. And that should apply to all these values there. Okay? Next example. So same type of questions, but only that in any part, maybe there is a slight change. The change in this case is the coefficient. I already talked about coefficient. And I said that when you have a coefficient, you only need first to divide all the 2 sides by the coefficient. So by this, I mean 3 divided on both sides leaves you with a tan 2 theta minus 15 equals to negative 2.3. That's the first part. Then, once I have this, I'll go for the working angle. Remember, I'm supposed to get the value of theta, given that theta lies between 0 to 360. So 2 theta will lie between 0 to 720. So the working angle would be shift tan without the negative 2.3. Shift tan 2.3 should give you a 66.5. Okay, then next process is I need to get the values for 2 theta minus 15. And those values should come from the place where tan is negative. So in which quadrants is tan negative? Tan is negative here and here, because obviously you can see in these two it's positive. So tan is negative in the second and in the fourth quadrant. So in the second quadrant, using this working angle, second quadrant angle should be 180 minus 66.5. 180 minus 66.5 should be 113.5 degrees. In the fourth quadrant, it will be 360 minus 66.5. And 360 minus 66.5 is 293.5. Once you get these two answers, remember this is 2 theta. The value for 2 theta should be between 0 to 720. So this is just between 0 to 360. So I need a pair of other two answers, which should be on every value. Let me add 360. So 113.5 plus 360 should give you 473.5. Then 293.5 plus 360 should give you 653.5. Close to 3720. So once you have those angles, we know the process of getting the value of theta. Now this is minus. In each case, I'll say 113.5 plus 15. The answer I get divided by 2. So it will be, if I work out all those 4 answers, I'll get the first one to be 64.25. The next one should be 154.25. The next one should be 244.25. Then last one should be 334.25. So those are the 4 answers. And again, if you look at them, you notice that they're always between what was required, 0 to 360. Okay, one more example for today. Okay, this is my last example for today's lesson. And looking at this carefully, you notice that now for this question, there is sine cos, something I already explained before. And something else you should also watch, apart from sine and cos, you notice that the angle in both cases is the same. So I said that when you come across such questions where there is sine cos, then the angles involved are the same. Think of the relationship between sine, cos, and tan. And the relationship is sine theta over cos theta equals to tan theta. So because of that, I'll have to rewrite this statement so that I'll have sine theta over cos theta equals to a value. So we should be sine this, I can see cos. So I'll collect like terms, divide on both sides by cos. So I'll have sine 2 theta plus 5 over cos 2 theta plus 5 equals to, then whole numbers on the other side, which will leave me with 6 over 3. So clearly, sine, cos, same values. So this statement is the same as tan 2 theta plus 5 equals to 2. Then now, we have this normal question I've been explaining all the way. So I expect actually not to do the whole question. My question was, given that theta lies between 0 to 360, find the value of theta in this statement. So once you get to this point, I want you to try, follow the process of how I've been doing the other questions, try to work out these questions until you get the final answers, which should be 29.2 degrees, 119.2 degrees, 209.2 degrees, and the last value, 299.2 degrees. That is it. So anyway, all these examples, especially the ones I said are from Form 4, questions that in an exam, when asked, they can be around 3 to 4 marks, sometimes 4 marks, sometimes 3 marks, mostly 4. So it's something that you have to take serious as a student. So this is the first part of these equations. Like I said, the trick is not in solving the questions. First of all, for this lesson, I just wanted you to be familiar with how to solve the questions. But where there can be a challenge is where the range here is not 0 to 360. We'll have values whereby the range can be some other different values. So if we had a range, even though it's supposed to be referred to as a domain, of not 0 to 360 something else, how do you deal with those questions? And that's where I'm supposed to start tomorrow, then plus some other things where the coefficient of theta can be a fraction. So again, if this is a fraction, how do you deal with such a question? So such things will be in our next topic. But for now, I think that should be enough. And you should review, go through it so that if at all you follow it, help you. Thank you.